Our next keynote speaker is Ms. Agneta, Director General of the World Nuclear Association. Ms. Riesing, please, you have the floor.
Good morning, ladies and gentlemen. It's a great honor for me to be here and a pleasure. And something has happened that has never happened before, is that I have more time than they gave me from the beginning. And I think that's because the previous speakers has been very timely and very, very well prepared. It is fantastic to be here at the IAEA to have this climate change conference right now, and I thank the acting DG Feruta and also the DDG Chudakov. It's absolutely the right timing. It is an important meeting, and it's also with a factual and scientific content. I've seen the program, I've gone through and looked at everything. It's absolutely fantastic. And we will also hear, as said in the beginning, about future technologies. I will concentrate on things that have maybe not been said already, so I'm not going to repeat everything important about climate change, everything important about need for new technologies. I will concentrate more on what is exactly now ongoing. So I come from the World Nuclear Association. I'm representing the global nuclear industry. So all other organizations are representing governments, and it's also, I think, very timely and good to have industry talking about the experience and what the industry can do. So the World Nuclear Association has 184 members in 43 countries. And I can tell you, the global nuclear industry is committed to delivering what it needs to do to save our planet from climate change. Our technology is ready, our supply chain is ready, and our people are ready. But to achieve the targets, to have success, we also need supports from government. Otherwise, the nuclear option will maybe fade away or not deliver its full potential. We see that nuclear is moving higher on the agenda. We have since a couple of years, the work started in Nice Future. We will hear about that later in the program as well. That means the Nuclear Innovation for a Clean Energy Future initiative by 3 governments, US, Canada, and Japan, and then many other governments are now supporting this program. We see also that clearly, we have heard from IPCC, but I will give a little bit my view in a slide soon. And IAEA has made the first nuclear report this year, the first one in 18 years. So we see this development that nuclear is now central and included in all the discussions. And if I may, I would just mention specifically here that the UNECE had its first nuclear session. They are working with the Sustainable Development Goals, especially on energy, and they had nuclear included for the first time also in the end of last year. And they have their flagship program, Pathways to Sustainable Energy, and where the industry is working together with the UNECE to contribute information on the technology option, specifically nuclear. And also in collaboration with UNECE, IAEA, and NEA, the role of nuclear energy in sustainable development on entry pathways. So this is work that's ongoing. I'd like to bring out a few summaries. And IAEA, as I made the nuclear power in a clean energy system, launched May this year. And a failure to invest in existing and new nuclear plants in advanced economies would have implications for emissions, for costs, and for energy security. That was one of the conclusions. The other one, strong policy support is needed to secure investment, need to reform policies to ensure competition on a level playing field. Electricity markets should value the clean energy and energy security attributes of low-carbon technologies, including nuclear power. Licensing processes should support new construction by not leading to project delays and cost increases that are not justified by safety requirements. Also, the World Energy Council made a report, a scenario report on the future of nuclear energy, and where nuclear energy increases in all scenarios, and also saying that nuclear energy is one of the most cost-effective sources of electricity in many countries, and that nuclear energy contributes to clean and low-carbon energy and system stability, and this is not currently valued and compensated for, because usually only generation costs are compared. So it was a fantastic presentation by Mr. Lee, the chair of the Intergovernmental Panel on Climate Change, and he talked about that we need to have a rapid transition. We need also to have a scalability. He mentioned 2.5 times an average on the scenarios in the report from last year, and I want to go in the middle because he said there was either negligible or tenfold increase. But I like to talk about the representative middle-of-the-road scenario. That's where nuclear increases 5 times. That's a scenario where there's not so much disruption to life. It's not that everybody has to go with a solar-powered sailing boat from Europe to US. There's other ways to travel. We can do a lot of these things that we do today. We can keep on with this type of life, modern life we have, but nuclear has to do much more to electrify processes and systems. And of course, then you need to have a lot more nuclear, and that's just 5 times growing. And then there would be roughly 25% nuclear by 2050. So we are looking to the future. We see that nuclear is already contributing. It was discussed already. Nuclear is contributing a lot, specifically because it's low carbon, and there's not so many low carbon options out there that have a large contribution. But how will it look? I think it was also well expressed by Mr. Lee. It's now an opportunity, because this is not written exactly how this development will go. It's up to us, and it's up to action. It's not so much up to discussion anymore, because all things are pointing in the same direction. So I like to bring this example. Concentrate first on 1974. How it looks there. You see a large dependence on fossil fuels. There is also some hydro and very little nuclear. This is in the middle of the 70s in France. France have decarbonized. Other countries have done so too, but this is one of the best examples. And you see all the blue, so much nuclear energy that now have totally decarbonized the electricity in France, as well as taking care of all growth in demand. So this is a very good example. And then you might say, oh no, we cannot do this today. Of course we can. It was done in the 80s, and other countries did the same in the 70s and 80s. We can do it again, and we can do it even better. So we see that nuclear energy have this speed, and we need this for the society to be able to deploy the technologies. And nuclear energy gives rapid, large-scale, long-lasting decarbonization. You don't have to redo it again, because these plants will most likely run for 80 years. Today we have capacity factors around 80% as a global average. And very interesting to see also a very young reactor, newly starting operating, have capacity factors over 80 years, or 80%, as well as reactors becoming 45 and 50 years, also having capacity factors of 80%. That means you are building a very big machine, and it is operating 24/7, irrespective of weather and seasons. And this is what you like to do when you invest, of course. Then some would say, no, construction times are so long we cannot have nuclear energy. Of course we can. And we now again have to look at the effects. If we look at those reactors that have started operated from 2000 and up till today, typically the construction time is 5 to 7 years. But also, of those 90 reactors that have started operating and delivering electricity from 2000 up to now, 27% of those reactors were built in less than 5 years. So it is fast, it is rapid, and it is scalable, long-lasting. Look now at the pictures. So I had many slides. I took away the slide starting from 2016, so now you only will see what has happened 2018 and 2019. So a lot of reactors are coming online, and we have a great development. And we also see in the coming 2019, the coming 2020, and also the end of this year. Of course, not all of the reactors will start in 2019. Some will maybe move to 2020, but still it's a lot of new reactors coming online. And it is important here to also see that this is based on 20 designs. The smallest one, 35 megawatt. The largest one, 1,720 megawatts. This is 47 reactors in the period from 2016 to 2020, a 5-year period. 9 of these designs are built for the first time. These reactors, during this 5-year period, is built in 11 countries, whereof 2 are newcomer countries. And it is absolutely crucial that we have more newcomer countries. And it is very important that IAEA is assisting countries and supporting countries in what's needed in the development, because we need these newcomer countries to have clean electricity, affordable electricity for their people. The global nuclear industry has set a goal to supply 25% of the electricity before 2050. That is roughly 1,000 gigawatt nuclear capacity. And we need this all because of clean and reliable low energy mix is important for all of us. And then again, you might think this is a hard task, and it is. It is ambitious, but it's also feasible. And if you look at this slide, if you look at the blue, you see in 2014, we were around 5 reactors per year that was added to the grid, around 5 gigawatt per year. That was like that for around more than 20 years, that very low level. In 2015, it doubled, and we have been to this doubled level that is 10 gigawatt per year. So this is good. So we can say that the industry has been able to double here. But if you look at the green bars is the target, the goal, the harmony goal. And from today's level, we need to double up and even triple, because it's not double first and then triple, of course, from that level. So triple from today's level. This, the industry cannot do on their own. Here is an opportunity for governments and in fact also a requirement for governments to do the policy support. If we go back to the mid-80s, you see this was the pace that was used to add new nuclear to the grid. More than 30 big reactors per year. So the Harmony Programme is a framework of action which the nuclear industry is working on. And this is to reach out to key stakeholders, to understand the options and the potential of nuclear and what needs to be done to make use of this potential. We start with to create a level playing field. Nuclear energy has to be treated on equal opportunity as other low-carbon options and recognized for its value because it's a reliable and resilient low-carbon energy provider. Is this an important target? Yes, it's a very important target. There are dozens of well-performing reactors around the world that are at risk of early closure because of the failing markets. In many countries, the governments are given to the markets to sort out all those very complex things. Markets will not sort out these things. This has to be sorted out by governments, putting the right frameworks in place. And as you heard from the acting DG Ferruta, he mentioned specifically 24/7. Nuclear reactors delivers 24 hours a day, 7 days a week, but they are not getting paid for this. And that's why very beautiful reactors like this one might close down or closing down a couple of the reactors there. We need to increase decarbonization. We need to increase electrification to manage to increase decarbonization. We need to have electric vehicles. We need to have heat, industrial processes, and desalination. All these things need more electricity. And it's interesting with this country as an example, it has been the fastest country in the world to add nuclear power. This is Sweden, and fastest in the world to add nuclear capacity per capita. But I can tell you in this part of the world here, all the trains are already running by electricity, and that is not possible to put more timetables or more trains on because there's not enough electricity. And still the plan is to close 2 reactors here. So there is lots of things to do to make things correct and good. And not always easy, but some things seem to be quite straightforward. This was mentioned already by Bill Magwood. So this is system cost. I have a little different graph showing the system cost for gas, coal, and nuclear, which is very, very low. That means they are easy to transport in the grid system. And when you see the balancing cost and utilization cost and other grid costs for the wind and solar, you see that that is quite adding a lot of cost to the society. This is a little bit older graph. This shows the levelized cost of electricity. It's on the global level. And you see here again, nuclear is one of the cheapest options. Nuclear is the blue, and this is from 2015 from IAEA and OECD NEA. And then some people would say, okay, this is 7% discount rate. Yes, if you go lower to a lower discount rate, nuclear becomes even cheaper, even better value for the society. To have the levelized cost of electricity is providing a good comparison, a fair comparison, but it does not include system cost, which you also should include. And as I showed from the previous slide, system cost is cheap for nuclear, one of the cheapest. Also, we need all the renewables as well. But saying that the price of renewables has gone down, we need to now look one step further. So I go now to an example, China. China is using nuclear energy. They are very advanced in solar PV and wind as well. And this is an example of levelized cost of electricity, where you see that nuclear, even today and up to today, is one of the cheapest options. So it is important. And then if you then, in addition, add system cost, of course, nuclear comes out as one of the most cost-competitive energy sources for a society to have. So we also need to create harmonized regulatory processes, provide a more internationally consistent, efficient, and predictable nuclear licensing regime, and to facilitate significant growth of nuclear capacity, and also timely licensing of innovative designs. And this is, of course, very important if we are going to do a lot of reactors and bring them to new countries, to new areas, and also specifically for small modular reactors. We need to have them in many different countries. We need also to have a system that you don't have to relicense everything when you move across the border. We know the airplanes can land in different countries, even if they're designed in one country. And this is, according to those lines, we have to move in that direction. I like to quote IAEA, that the variety of national regulatory requirements causes many drawbacks for the entire nuclear industry, including developers, vendors, operators, and even regulators themselves. This results in increased costs and reduced predictability in project execution. So this is, again, an important target. We also need to create an effective safety paradigm. We shouldn't focus on the genuine public well-being, because health, environment, and safety benefits of nuclear has to be appreciated and better valued, especially when it's compared with other energy sources. And we see here the safety of electricity generation. This is from OECD countries, and you see that nuclear is, again, the one with accident fatalities, the lowest per produced terawatt year. And what we otherwise have, we have emissions. So with nuclear, there might be some vapor coming out, but it's, of course, only humidity, while coming out from our transport system, there is a lot of dangerous gases, including carbon dioxide. And if we compare with carbon, specifically quite a lot of coal, it's more than 2,500 million tons avoided of the nuclear we are using today. And that is equivalent to remove 400 million cars from the world's roads. So nuclear reactors, they are the low-carbon backbone of the electricity system. They operate in the background, day in and day out, often out of sight, out of mind. They are the silent giants we rely on daily. They are meeting the Sustainable Development Goal 7, affordable and clean energy. Sustainable Development Goal 13, climate action. And I also like to mention one thing in addition. It was from the Ministry of Energy in United Arab Emirates. They had the World Energy Congress just less than a month ago. And they said, yes, we know this, that nuclear energy will give us low-carbon electricity. But not only that, they will give us the jobs, interesting jobs, and a lot of economic growth. And thanks to what we are doing in UAE now, we see that some of our companies in the supply chain, they are now getting sort of nuclear quality. That means they have to step up in order to be suppliers. And now they can act on the world and also export from the supply chain. So they see an enormous economic growth. So I'm now turning to you. If we have now been able to double the number of reactors that we are putting onto the grid, and from this level we need to triple. We need to have governments to take this opportunity, make use of the support IAEA is giving, make use of all the information and experience that is in the nuclear industry. As I said, the supply chain is ready. And government must take action to allow nuclear industry to deliver the harmony goal, to enable the world to meet the climate challenge. Thank you very much.